Let x, y, and z be three independent random variables with x follows a normal distribution with the parameter mu and sigma, and y and z follows a uniform distribution from 0 to 2. We also know that these two equations hold. We want to find mu and sigma. Before we solve the problem, let's review a few facts we need. The first one, if a cosine is a uniform distribution from A to B, then the expected value of a cosine is the average of A and B. The variance of a cosine is 1 over 12 times B minus A squared. The second fact, if a cosine 1, cosine 2 to cosine n are all independent, then we have the function of them, f1 cosine 1, f2 cosine 2, and all the way to fn cosine n are also independent. So this implies that the expected value of f1 cosine 1 times f2 cosine 2 all the way to fn cosine n is equal to the expected value for f1 cosine 1 times the expected value for f2 cosine 2 and all the way to expected value of fn cosine n. So in other words, we can move the expected value inside of this production, right? Now, let's go back to the problem. First, let's solve the expected value of y and z. So expected value of y is equal to expected value of z, and this is equal to, now y and z is uniform from 0 to 2 using the fact here. The expected value of y and z is going to be 1/2 times 0 plus 2. So it's 1/2 times 0 plus 2, which is equal to 1. Now the variance of y and z, now we're going to need the second formula here, is equal to 1 over 12 times 2 minus 0 squared, which is equal to 1/3. Now, we also want to compute the expected value of y squared because we have y squared here. So now first, the variance of y is equal to the expected value of y squared subtract expected value of y squared. So this implies the expected value of y squared is equal to the variance of y plus the expected value of y squared. Now the variance of y is 1/3, so it's 1/3 here, plus the expected value of y is 1, so it's plus 1 squared, and this is equal to 4 over 3. Now go back to these two equations here, and we can use the formula here to write down this equation, right? So this is the first equation is equal to the expected value of x squared times expected value of y plus the expected value of x times expected value of y times expected value of z, and this is equal to 15. The second equation, this equation is equal to the expected value of x times expected value of y squared plus the expected value of z times expected value of x squared, and this is equal to 16. Now, we already computed that e of y, this one, is 1, right? And ey and ez is also 1, so we have computed here, right? So now this one, ey squared, and we computed ey squared is equal to 4 over 3, so this is 4 over 3 here, and e of z is 1, right? Now with all this with all these items already computed, we can rewrite this equation. So this equation can be rewritten as ex squared plus e of x is equal to 15. This is the first equation. The second equation, 4 over 3 e of x plus ex squared, and this is equal to 16. Now this equation has two variables we need. One is ex squared, one is e of x, right? So we can easily solve this equation. So e of x is equal to 3, and e of x squared is equal to 12. Now we have mu is equal to 3. Now we also need to compute the sigma square. Now sigma square is equal to the variance of x is equal to the expected value for x squared subtract expected value of x squared, and the expected value of x squared, we solve this equation and we get e of x squared is equal to 12. So this is 12. Subtract e of x is equal to 3, so this is the 3 squared, and this is equal to 3. So sigma squared is equal to 3, so this implies sigma is equal to square root of 3. Thank you for watching.